Everyone, this is Mrs. Snowbeck, and today we are going to do Unit 8, Notes 8, and we're going to talk about finding areas of regular polygons. And remember, polygons are things like pentagons and hexagons and octagons. And one of the things that polygons have is an apothem. And if you look closely at this picture over here on the left, you'll see segment PF. Segment PF is an apothem. It's a segment that is perpendicular to a side of a regular polygon from its center. It's kind of like, imagine you have a shape like this, like a pentagon. It's kind of like a radius. It starts in the center and then it goes to one of the sides and it's perpendicular to that side. Also, another vocab word is central angle, and we've learned about central angles in circles. Well, central angles in polygons are very similar. An example of a central angle that I see here is angle APB. So go ahead and look at that angle. Angle APB is right here. Notice how its vertex is right at the center of the polygon. P is at the center of the polygon. Okay, so let's go down to number 1. Number 1, they want us to try to identify lots of things on this picture. For example, what is the center? Well, if you look closely, see how point K is right in the middle of the circle and K is the center. Remember, a radius starts in the center of a circle and goes to the edge. So like segment KG is a radius. And then there's another one, segment KH. That's also a radius. Kind of take a look at those, where they are on the picture. The apothem does not go all the way to the edge of the circle. The apothem starts in the center and goes to the edge of the polygon. So segment KL is an apothem. And then finally, central angle. The central angle that I see here is angle GKH. Angle GKH has its vertex K right at the center of the circle. Now, let's say you wanted to figure out how big that central angle is. Do you remember that a circle is 360 degrees? Well, if I think about the central angles here in this quadrilateral, there's one that I just marked. Then if I mark another one, right here is 2, right here is 3, and right here is 4. There's 4 central angles in a quadrilateral. Well, they form a circle, which is 360 degrees. So if we take 360 and divide by 4, we get 90 degrees. That means each of those central angles is actually going to be 90, 90, 90, 90. Okay, will you please pause the video and try number 3? Number 2. All right, let's go through the answers. The center is R. A radius is segment RK. Another radius is segment RL. The apothem is segment RS. The central angle is angle KRL. And each central angle, well, remember, this is a central angle. This time we have a hexagon. So there's going to be 1, 2, 3, 4, 5, 6. There's going to be 6 angles in here. So we take 360 divided by 6 this time, and each of those angles would be 60 degrees. All right, moving on to number 3. Let's find our first area of a polygon. This time we're going to find the area of this regular hexagon. Regular means all the sides are the same length. And right here it's telling us the side lengths are 9.23. So this side is 9.23, this side is 9.23, etc., all the way around. Well, imagine breaking this hexagon up into triangles. To find the area of a triangle, it's base times height divided by 2. Well, if you look closely at this triangle, the base is 9.23, the height is 8. We can find the area by doing 9.23 times 8 divided by 2. And if we type that in our calculator, the area of that triangle is 36.92, and it's going to be centimeters squared. That's the one triangle right here outlined in blue. But think about this regular hexagon. It's going to have 1, 2, 3, 4, 5, 6 triangles. So if we wanted to get the area of the whole hexagon, we could just take our 36.92 and times by 6, because it will take 6 triangles to fill that up. And our final answer is 221.52. And remember, it's units squared, so centimeters squared. Let's move on to number 4. So again, we're going to break this polygon up into triangles. Imagine I have a triangle. I'll outline it in blue right there. Do I know the base of the triangle? Yes, it's 20. Do I know the height of the triangle? Yes. So let's start by finding the area of the triangle, which is base times height divided by 2. So for the area of the triangle, it's going to be 20 times 13.8 divided by 2. So the one triangle comes out to be, if we type that in our calculator, 138 meters squared. Now remember, we want to find the area of the whole pentagon. So you have to think about, it's got 1, 2, 3, 4, 5 sides. It's going to take 5 triangles. So our last step is going to be multiply by 5. We're going to need 5 of those, which is 690 meters squared. And that's the area of the regular pentagon. Let's move on to number 5. You can see this side length right here is 8, and it is a regular hexagon. So this side length right here is also 8. Let's draw in a triangle, and let's find the area of the triangle. Remember, base times height divide by 2. So 8 times 8 divide by 2. I believe that comes out to be 32 feet squared. Now remember, that's only one triangle. Think about a hexagon. A hexagon is 6 sides. You can count them if you want. 1, 2, 3, 4, 5, 6. So we're going to have to take 32 times 6. And that turns out to be 192 feet squared. Okay, are you ready for the really, really hard one? This one's crazy. We're going to try to find the area of this regular octagon. But as you can see, when we make our triangle, we know the base of the triangle is 11, but we do not know the height of that triangle. And it's going to take a lot of work to get the height of that triangle. So here's the steps that we go through. I call this the 6-step process. Step number 1 is we have to find a central angle. So that means figure out how big this angle is right here. Well, this is an octagon. So remember on the front side of our notes, we did 360 and divided it by how many central angles there are or how many sides there are. Well, there's 8 sides here. 1, 2, 3, 4, 5, 6, 7, 8. So we're going to divide by 8. That central angle is 45. Step number 2 is we're going to divide by 2. So we're going to take that 45 and divide by 2, and we're going to get 22.5 degrees. So what we just figured out is this part right here is 22.5 degrees, and this part right here is 22.5 degrees. Step number 3 is we want to figure out the base of the triangle. Well, we already know the base. It's down here. It was given to us. It's 11. So luckily, we don't have to do too much work there. But the next step is find the height of the triangle. And this is where we might have to use SOHCAHTOA. Oh boy, we haven't used this for a while. So I want you to take a look. I'm going to outline the triangle in blue. I'm going to show you this triangle right here. Do you see how 11 is all the way across? So if we take 11 divided by 2, we get 5.5. This half is going to be 5.5. This half is going to be 5.5 on the base there. I'm going to show you that blue triangle. So I'm going to redraw it. Here's a right angle. This is 5.5, and this is 22.5, and we want to find this side right here, which will be the height of our triangle on the octagon. we're going to have to use SOHCAHTOA. So from our angle, the 5.5 is opposite. The x is adjacent. Think about O and A. O and A go with TOA. So we're going to say tangent, T for tangent, of 22.5 equals 5.5 over x. Opposite over adjacent. Now this is one of the hard ones. X is on the bottom, so we're going to have to multiply by x because we do not like that on the bottom of a fraction. And then what we have is x times tangent 22.5 equals 5.5. Divide both sides by tangent 22.5. Those cancel out, and then we're going to have to type that into our calculator. It should come out to be 13.28, and that is the height of our triangle. Okay, so that was tons of work, but we're still not done. Our next step is now we know the base and the height of our triangle. This height is 13.28. I'm going to put it on my picture there. You get the idea. So, area of our triangle. Remember, the base is 11. The height, 13.28. Base times height divided by 2 gives us the area of a triangle. That turns out to be 73.03 inches squared. And how many triangles do we need to fill up an octagon? Well, remember, octagon is 8. So lastly, we're going to take 73.03 times 8. Holy buckets. We get 584.24 inches squared. And that is the total area of your regular octagon. If you show that to your parents, their minds will be blown. They will not even comprehend all of this stuff you just did. All right, well, we're done with the notes. Go ahead and try Unit 8, Practice 8. Have a good one. Bye.